Hi everyone, I'm Sophia Abdunor, and I'm excited to take you on a journey that connects two of my favorite things, engineering and Syriac history. This presentation is part of the Syriac Heritage Project, which works to preserve the language, culture, and intellectual legacy of Syriac-speaking communities. What I'm about to share might surprise you, because Syriac scholars played a much larger role in history than most people realize. To start with some context, the Syriac Heritage Project is a completely volunteer-run nonprofit organization. Its mission is to preserve the Syriac language and culture and to teach people about the lasting contributions of Syriac-speaking Christians in science, medicine, math, and philosophy. Beyond preservation, the project also engages the public with a website, a YouTube channel, and a growing collection of educational articles and newsletters. We also have our socials linked on the side, so please check them out if you want to learn more. And starting with what we'll cover in this presentation, first we'll explore the historical role of Syriac in science and math, and meet some of the most influential Syriac scholars, and look at how they advanced specific branches of math and astronomy. We'll also explore their key role in the translation movement and the thriving intellectual centers where they worked, and the legacy that they left. So, what exactly is Syriac? Syriac is a dialect of Aramaic, part of the Semitic language family, which was once spoken widely across the Middle East. By the 6th century CE, it became the primary language for many early Christian communities in Mesopotamia and the Levant. Syriac linked Greek, Persian, and Indian knowledge, and eventually served as a conduit to Arabic scholarship. Syriac represents the third largest body of early Christian writings after Greek and Latin, and much of what we know of classical science and medicine survived because it passed through the hands of Syriac scholars. This chain of knowledge is what allowed classical learning to survive and flourish. Now, let's meet some of the brilliant figures who carried this knowledge forward. These people weren't just translating, they were writing, publishing, and shaping science. First, we'll start off with some of the early century Syriac scholars. First, we have Sergius of Rusciana, who was a 6th century priest and physician. He translated major works by Galen and Aristotle into Syriac, bringing medicine and philosophy into the reach for Syriac-speaking scholars. He also wrote commentaries that introduced Syriac readers to logic and foundations of scientific thinking. In many ways, he was an early science communicator, making Greek ideas accessible and relevant to a new audience. Moving on to the 7th century, we have Severus Sebokets, who stands out as a bishop and passionate astronomer. He is credited with one of the earliest mentions of Hindu numerals, including the concept of zero. His writings include treatises on constellations and the astrolabe, and he worked to dispel superstitious astrology in favor of careful observation. Another key figure is George, Bishop of Arab tribes. Active in the 8th century, he was a student of Jacob of Edessa and became known for his work in philosophy, theology, and liturgy. After Jacob's death, Jacob completed his massive encyclopedia work, the Hexaemeron, which reflects his intellectual work, which was revolutionary of the time. His title, Bishop of Arabs, reflects his unique position at the crossroads of Syriac, Arab, and Greek cultures, and he helped ensure that Aristotelian logic continued to circulate in a rapidly changing world. Then we have Hunayn ibn Ishaq, a 9th century Christian polymath. He was fluent in Greek, Syriac, Arabic, and Persian, and he became one of the most influential translators of his era. Hunayn translated more than 100 works by Galen, providing the foundation for Islamic medicine, and wrote the original medical treatises himself, including the 10 treatises of the eye, which became a cornerstone for studying eye disorders. Another brilliant mind of the 9th century was Thabet ibn Qurra, a mathematician, astronomer, and physician. He contributed to geometry, refining the Pythagorean theorem, and developed methods to identify amicable numbers. In astronomy, he proposed the theory of trepidation. He also worked in physics, writing the law of the lever, showing how Syriac scholars were as creative as they were careful. As we move into the Syriac Renaissance, we get introduced to Jacob Bar Shako. He emerges as an encyclopedist and theologian. His Book of Treasures and Book of Dialogues wove together philosophy and theology and natural science, reflecting a rich intellectual tradition that blended spiritual and scientific thought. Next, we have Gregory Barbarous. He's often called the last great Syriac polymath and represents a high point of his tradition. He produced monumental works in history, theology, philosophy, and science, including the Chronicon Syriacum and the Ascent of the Mind, which synthesized centuries of Greek, Syriac, and Arabic knowledge. His writings ensured that Syriac intellectual heritage would endure long after its political centers declined. Finally, we have Ignatius Nematala, a patriarch of the Syriac Orthodox Church. He contributed to the reform of the calendar that became the Gregorian calendar we use today. His involvement shows that Syriac scholars influenced global scientific developments even into the early modern period. Next, we're getting into the areas of study for Syriac scholars, most of which were remarkably broad. First, in arithmetics, they developed techniques for calculating the date of Easter, which required precise lunar and solar computations. They were also instrumental in spreading the concept of zero, which would later enter Arabic and then European mathematics. In geometry, they translated Euclid's Elements, and scholars like Thabit Qura questioned and expanded Euclid's works. In astronomy, they wrote treatises on the astrolabe, charted planetary motion, and even contributed to cometology, combining careful observation with inherited Greek models. These studies were not merely abstract, they had real applications in navigation, calendar reform, and the daily rhythms of Christian life. And here are some of the examples of some of the practical applications we mentioned for each of the branches. And then moving on forward for Syriac as a conduit, between the 4th and 10th centuries, Syriac scholars powered what historians called the Greco-Syrio-Arabic translation movement. Greek texts were first translated into Syriac, then annotated and preserved, and finally into Arabic, where they often were translated in that circle by the same scholars. So here we see a great visual of how these texts moved through these intellectual houses and how they eventually got translated and later moved throughout the world. And the pipeline of knowledge fed directly into the House of Wisdom in Baghdad, which helped spark the Islamic Golden Age. Without Syriac, vast portions of Greek science, medicine, and philosophy would have been lost to history. Now, we move on to language integration. Syriac didn't just transmit knowledge, it shaped scientific vocabulary itself. The language absorbed Greek words like geometry, square root, and astrolabe, and these terms were later passed to Arabic and then eventually to Latin and European science. Even the word algebra has likely roots in Syriac. This process shows that Syriac was not a passive conduit, it was an active shaper of how scientific concepts were expressed and understood. Next, we're going into schools and intellectual centers. The thriving intellectual life of Syriac-speaking communities was sustained by their great schools. Here, we're going to cover all of these 3 great schools, starting off with the School of Edessa, which was an early center for learning, producing generations of scholars and a vast body of manuscripts. When Edessa closed, the School of Nisibis rose to prominence. Often called the first Christian university, it trained theologians, philosophers, and scientists, and its influence stretched all the way to Asia. Next, we have the monastery of Kenesre, which specialized in philosophy and translation. It educated many of the scholars we've discussed and produced bishops and patriarchs who preserved and transmitted the scientific knowledge. These centers were not isolated ivory towers, they were deeply embedded into their communities, and their intellectual output traveled far, influencing Islamic scholars and through them medieval Europe. Next, we're going into some of the legacy and impact. The Syriac of Syriac scholars is one of preservation, innovation, and cultural connection. Syriac scholars safeguarded Greek knowledge, expanded it with insights from Indian and Persian traditions, and passed it along to Arabic-speaking communities and beyond. They were not passive scribes, but active participants in the evolution of scientific thought. Their legacy survives not only through manuscripts, but also in the vocabulary and methods of modern science and mathematics. Before we get into the bibliography, I just want to say thank you for joining me on this journey through Syriac science and mathematics. I hope this presentation leaves you with a new appreciation for how knowledge travels across languages, cultures, and centuries, and how Syriac scholars specifically helped build the intellectual foundation of the world we live in today. If you'd like to explore further, the Syriac Heritage Project has wonderful resources online for you to dive into. And of course, an amazing shout out to the creators of this slideshow. Without their formatting, the slide would not have been as interactive and full of graphics as it is now. And of course, you can read all of these references at your own pace if you're curious. But once again, credit to SlidesGo for the template for these slides.